everyone. In the previous session, we have learnt about the context-free grammars and how to eliminate the useless symbols. So, in this class, we are going to learn how to eliminate the epsilon productions. So, epsilon productions in the grammar are unnecessary if we are not trying to generate epsilon itself as a string. So, such productions can be eliminated from the grammar while keeping the rest of the rules that determine the strings that can be derived from the grammar. So, now we will see the procedure for eliminating the epsilon productions from the given grammar while protecting the language that is generated by the production rules of the grammar. So, first of all, when we look at the epsilon productions, so what is an epsilon production? So, any epsilon production is the one which is in the form of some variable, I am going to write it as A goes to epsilon. So, this is an epsilon production, and here the variable A is called as a nullable variable. So, nullable because it is not generating a valid symbol, so that is why it is called as a nullable variable. So, what is the aim of elimination? So, the aim of elimination is given a grammar G which is equal to VTPS. So, we know the 4 different attributes of the grammar, that is the variables, terminals, production rules and the start symbol. So, we are going to generate an equivalent G dash which is equal and it has got the same 4 attributes, but we have to be careful that the new G dash that we are going to generate is equal to the old grammar, that is L of G, that is the original grammar minus the epsilon. So, it will not have any epsilon productions in the grammar. So, what are the steps that we have to follow to eliminate it? So, step 1 is to find all the nullable variables. So, this is a kind of a production that we are looking for initially, and any variable that tends to be epsilon is called as a nullable variable. So, we will find out all such variables. What is the second step that we do once we have found out all the nullable variables? So, we look for the production which is in the format of A goes to x1, x2, x3 up to some xn. So, these are anything that is allowed on the RHS of a context free grammar. So, in these symbols we are going to identify all the nullable variables and we are going to substitute each of the nullable variable with epsilon. So, nullable variables are replaced with a epsilon and the resultant production is added to P dash. So, this is the procedure that we are going to follow. Also, we will preserve all the original productions and add them to P dash. So, this is the procedure. So, now we are going to look at the problem. So, in this problem there are 5 rules which is defined and we are going to eliminate all the epsilon productions from the grammar, but still the strings which is generated by the grammar should not change. Okay. So, first step is to identify all the nullable variables. So, the first thing that we are going to see is what goes directly to a epsilon. So, we have step 1. So, in the step 1 we will identify 2 productions, that is B goes to epsilon and C goes to epsilon. So, these 2 are nullable. So, B comma C. So, B and C are nullable variables. So, it is not sufficient that we look at into the direct productions that tends to be an epsilon. We have to look at more number of productions that can be epsilons. So, we will look for those variables also. So, if you look at here, there is a single terminal. So, it is not possible for the entire production to become epsilon. Here also we have a single terminal. So, it is impossible for the entire term to become epsilon. Therefore, S can never be nullable. Next is A goes to BC. So, we know that B and C both can be substituted for an epsilon. So, therefore, if I choose A goes to BC, B can also be substituted for an epsilon, C can also be substituted for an epsilon. So, therefore, this entire thing can become a epsilon. So, therefore, this A is also treated to be a nullable variable. Next, we will see B, C which is already considered. Then we will go to variable D and see whether it can be nullable. it has a single terminal, so this terminal can never become an epsilon. So therefore, B, C and A are nullable variables. So this is the end of the first step. Okay. So once we have done the first step, we have to carry out the step 2, where we are going to produce the productions in a different way, and that set of productions is P dash, and the original productions here are P. So the rule that we are going to follow is, first of all, we will write the first production. S goes to A, B, C, A, B, D. So here in this production, we are added the original productions to P dash. So also add all the original productions to P dash. So the originals are not changed and we keep it as it is. So the next step to follow is identify each xi which is nullable and replace the nullable variables with an epsilon and add it to P dash. So here A is nullable, B is nullable and C is nullable. So here we have to replace each one of them with an epsilon and write the resultant production to the P dash. So therefore, first time if I put epsilon in place of A, the production that I get is a B, C and A. Next, if we put epsilon in place of B, then we get A, C, A. Next, if we put our epsilon in place of C, then we get A, B, A. Next, if we put a epsilon in these two positions, A and B. So we have substituted one at a time so far. Now we will substitute two variables at a time. So A, B together, if we put it to epsilon, then remains C, A. So likewise, if we put B, C to epsilon, then we get a and A. Next is, if we put AC to epsilon, then we just get B and A. So we have done two variables at a time. Okay. So once we have done two variables at a time, so the last one is BA. Now three variables at a time is going to give us A. So these are the alternate productions that we have written, which in turn could be A goes to epsilon, B goes to epsilon and C goes to epsilons. Okay. So this is the case where somewhere in the production, if we chose to put S goes to A, B, C and A. Okay. And we imagine that B goes to epsilon, A goes to epsilon and C goes to epsilon is never there. Then if we wanted these three to become epsilon, then we could just directly use S goes to A. So this production. So this is the meaning of how we eliminate the direct epsilon productions, but indirectly we create productions that are going to be substituted in place of epsilons. Next, we will take up the next production. So the next production is A goes to B, C and B. So now here B and C are nullable variables. So therefore, we will find out what happens if you put epsilon in place of B, we get a C. We put epsilon in place of C, we get a B. Okay. So this is the end of A production. Next, B goes to, we just write a B. Epsilon is not written because we are generating alternate productions that will give the same meaning. Then C goes to small c and capital D goes to small d. So these are the different productions of the new grammar G dash. So now we will look at the second problem. So we will look at the four different production rules given for the grammar and identify the nullable variables as the first step. So now step 1 is identifying all the nullable variables. So B goes to epsilon and C goes to epsilon. So these two are directly identified as nullable variables. So we will see if there are more that can be substituted for nullable. So next we have A goes to BC. B is already nullable and C is already nullable. So therefore A is also a nullable variable that can be directly substituted for a epsilon in place of BC. Okay. So since A, B, C all three are nullable, we have S goes to A, B, C. So this A, B, C entirely can become a epsilon. So therefore S is also a nullable variable. Okay. So we have identified all the nullable variables here. So S, A, B, C, S, A, B, C, all of them are nullable variables. Now the second step is to replace the different production rules such that we can eliminate B goes to epsilon and C goes to epsilon, which are direct epsilon productions. So first we will pick up S goes to A, B, C. In A, B, C, we identify that A is also nullable, B is also nullable and C is also nullable. So each time we are going to substitute epsilon for each one of them and write the resultant productions. So first time A becomes epsilon, so we are left with BC. Second time B becomes epsilon, we are left with AC. Second time if we want to choose epsilon for C, what we have is AB. So one at a time is all over now. Next, two at a time. In case two variables were chosen to be epsilon while we retain the third one, that case. So if two of them are epsilons, so what we'll have is a A, B and C. So next, if three of them are epsilon, then we don't write epsilon productions here, because what we need is to eliminate the epsilon productions. So next, A goes to BC and A. So we write them as it is. B and C both are nullable variables. Therefore, first time when C is epsilon and the second time when B is epsilon. Next, we have B goes to B, A, C and epsilon. So we don't write the epsilon production, and we identify that A and C are nullable variables. So substitute epsilon for each one of them. So we get B, C, then we get B, A, and if both of them are epsilon, we just get a B. We'll choose C production now. So C goes to C, A, B. Do not write the epsilon production. A is also nullable, B is also nullable. So we'll write the productions now. So if first A is nullable, what we have is a CB. If B is nullable, we have CA. If both are substituted for epsilon, we'll just have a C. So these are the different productions that we write after eliminating the epsilon productions. The next topic is eliminating the unit productions. So anything which is in the form of A goes to B is a unit production. So we say that generally some X can derive a Y with single step. Anything which directly appears as A goes to B in only one step is called as the unit production. So we are going to eliminate all the unit productions. So the step 1 is to identify all unit pairs. So if we have anything in the form of A goes to B and C goes to D, so then A comma A is a unit pair and C comma C is a unit pair. So these two variables are generating single variables. So therefore A comma A is a unit pair and C comma C is a unit pair. Now suppose we have something as B goes to X and also D goes to Y. Then by the induction step of identifying the unit pairs, we are also going to write A comma A as the unit pair, and as a cycle B goes to X. Therefore, B comma B is also a unit pair. Next, we have C goes to D. So, C comma C is already identified as a unit pair. Next, we also have D goes to Y as a cycle. So, therefore, along with C comma C, D comma D is also identified as a unit pair. Okay. So, this is what we are going to find out in the induction step of finding out the different unit pairs. So, once we have found out all the unit pairs, step 2 is for every unit pair, which is in the form of A comma B, we replace every production of A with A goes to alpha, where alpha is the non-unit production of B, non-unit production of B. So, we will look at the problem now. So, first we have 3 different productions and we are going to do the basis step of identifying the unit pairs. So, directly we have S goes to B and B goes to A and A goes to B. So, S goes to B, B goes to A and A goes to B. So, therefore, the unit pairs are S comma S, B comma B and A comma A. So, we will consider the 3 variables that are leading to unit productions. Next, we will move to the induction step. So, in the induction step, we will find out if there are indirectly more number of unit pairs. So, first I am going to consider S comma S. Okay. So, once we have S comma S, we have the production S goes to B. Therefore, S comma B is also a unit pair. So, we will consider S comma B, which is generated as the unit pair. Next, we will see if we have B goes to something. So, B goes to A is present. So, therefore, S comma A is also a unit pair. So, next S comma A is considered. So, next we have A goes to B. So, therefore, we have come at S comma B. So, S comma B is already considered. So, stop looking into more number of unit pairs for the pair S comma S. So, next we are going to consider B comma B. So, B comma B. Next we will see if this B has got any unit production, which is B goes to A. Therefore, B comma A is also a unit production. Next, consider B comma A and we have the production A goes to B. So, therefore, B comma B is the unit pair. So, B comma B is already considered. So, therefore, stop looking into more number of unit pairs. Next, we will consider A comma A and we will see if this A has a unit production. So, it has A goes to B. So, therefore, A comma B is the new unit pair. Next, consider A comma B. Next, we have B goes to A. So, therefore, A comma A is the new unit pair. Okay. So, therefore, A comma A we have already considered. So, there is no need to look for more number of unit pairs. So, these are now the set of the all unit pairs which can be formed from the grammar. So, now we have all the unit pairs which are in the form of sum A comma B. We are going to do a manipulation where we are going to say A goes to alpha, where alpha is B's non-unit productions. So, therefore, we will perform that step here now. So we'll consider each one of them, okay, and we are forming G dash now. So G dash and its productions. So first we'll consider S comma S. So in case if we are considering S comma S, we are going to add S goes to, so that is nothing but this is A comma B. So therefore A goes to alpha. So alpha is B's non-unit production. So what is B in this case? It is S. So what are the non-unit productions of S? This is the only non-unit production of S, because B is a unit production, A0 is a non-unit production. So therefore here we are going to write A0. Next pair is S comma B. Next we are going to write S goes to B's non-unit production. So what is B's non-unit production? Only 1 1. Next we are considering S comma A. So the third one, which is S comma A. So S goes to A's non-unit production. So A's non-unit productions are 0 and 1 2. Next we are going to consider B comma B. So B goes to B's non-unit production, which is 1 1. Next B comma A, we write B goes to A's non-unit production. So A's non-unit productions are 0 1 2. Next A comma A. So A goes to A's non-unit production is 0 1 2. Okay. Next is after A comma A we have A comma B. So this is A comma B. So A comma B is considered. Again A goes to B's non-unit production. So B's non-unit production is 1 1. So this is the set of productions that we have formed. If we have to arrange them and write, so this becomes S goes to A0 or 1 1 or 0 or 1 2. So this is how we write the first rule of the grammar. So the second rule is B goes to 1 1 or 0 or 1 2. So this is the second rule of the grammar. So this is A goes to 0, 1 2 or 1 1. So this is the set of the grammar rules that we have formed for the original grammar that we wrote here. So this included the unit productions, but here we do not find any unit productions. But still the strings that are formed by this grammar will be same as that. So through this procedure what we have observed is this unit production is taken off. So in place of B we have A and 1 1. So therefore we have A and 1 1. So here A is still not allowed, okay. So A is not allowed. So therefore instead of A we write 0 and then we write 1 2, okay. So that is how we eliminate the unit production. So we can see here after we did all the procedures we have got the same production. So it has got A0, it has got 0, it has got 1 1 and 1 2. So just by eliminating a single alphabet from here we are substituting all the possibilities for that alphabet. If we want to look at this example also, here A is not allowed, okay. So instead of A what is possible? 0 is possible, right, and in place of A what else was possible? 1 2 is possible, right, and then B is possible. So B's possibility, which is 1 1, is already present. So this one is what we are looking for in the second. So have we got the same thing? So we have 0, 1 1 and 1 2. So that is how we have eliminated the single symbols, and in place of them we have substituted all possibilities for that alphabet. So that is how we are going to eliminate the unit productions. So we look at the second problem now. So look at the different productions and try to identify the unit pairs. So first of all, we have B goes to C, C goes to D, D goes to E. So therefore, B comma B is a unit pair, C comma C is a unit pair, and D comma D is a unit pair. So once we have identified these things, we will go to the induction step and identify if more number of unit pairs can be formed. So therefore, we will go to the induction step. So we will consider the first pair first, that is B comma B, and we will see if this B goes to any other unit production. So this goes to B goes to C. So therefore, B comma C is also a unit pair. So consider B comma C. C check if the C goes to a unit production. So C goes to D is there. So therefore, B comma D is a unit production. Consider B comma D. So do we have D goes to E? So therefore, B comma E is a unit pair. Consider B comma E. E has got no unit productions. So therefore, we will stop. Next, consider C comma C. So C goes to D. So therefore, C comma D is a unit pair. So we write here C comma D. Check if D has a unit production. So we have D goes to E. So therefore, C comma E is the new unit pair. Consider C comma E. E does not have any unit production. So therefore, we are going to stop. Next, consider D comma D. We have D goes to E. So therefore, D comma E is the unit pair. Consider D comma E. So E goes to, we don't have any unit production. So therefore, we will stop here. So these are the set of all the unit pairs that are there for this problem. So we will move to the step 2, where we will consider any unit pair which is in the form of A comma B, and we will replace it with A goes to B's non-unit production, B's non-unit productions. So therefore, so the first pair is B comma B. So B goes to, here this is A and second one is B. So therefore, this is B goes to. So just like we have here A goes to. So B goes to, B is non-unit productions. So B's non-unit production is small b. Next is B comma C. So next, C is non-unit production, there is nothing, so we do not write anything. Next, B comma D, and D is non-unit production is B goes to B capital C. Next we have B comma E. So therefore, for B comma E, E's non-unit productions are D A B. Next we have C comma C. C goes to, we don't have any productions, so we do not write anything here because there is no non-unit production for C. Next we have C comma D. D's non-unit production is C goes to BC. Next C comma E. So we have C goes to E's non-unit production, so D and AB. Next D comma D and D comma E. So here D goes to D's non-unit, so it is BC. Here also D goes to E's non-unit, so D and AB. So we will write the productions here. So these are the grammar rules. So the grammar rules are B goes to B or BC or D or AB. So here we can see that everything is a substitution for a single variable. So therefore we have written it in a single line. Then C goes to BC or D or AB. D goes to BC or D or AB. And we'll write the rest of the production rules as it is. We have S goes to AB, S goes to AB, capital A goes to A, then we have B already, C is there, D is there, and then E goes to D and AB. So this is the rules of the grammar that we produce after eliminating all the unit productions. So this is the end of the class.